Hello and welcome to today's class. Today's class will look at several past questions in the study of mirror formula. So last class we established the idea of mirror. We look at the concave and convex mirror, the concave lens and convex lens. We look at the formulas attached to them. We also look at several things to note when it comes to mirror. To have the link to our introduction to mirror, I'll leave a link in the video description. So check this video description. So before you start solving past questions with us here, do want to watch our introduction to better understand how we're going to be applying these formulas we have learned in our previous class. So I'm urging you to watch our introduction to mirror formula. I'll leave the link in the video description. After that, you can now proceed with this past questions video section. All right, we'll be looking at several past questions in the study of mirror. Before I move on, let's kind of recall some concepts we learned in our last class, right? So we said when it comes to mirror there, we said we have for the concave mirror for concave mirror or concave lens there, that the formula is given by 1 over f is equal to 1 over v plus 1 over u, or 1 over u plus 1 over v. That's concave. For convex, we said this one is given as 1 over f is equal to 1 over u minus 1 over v. So better still, let's put u first before v. All right, let's follow this pattern. So I have this concave and convex. Then look at the idea of magnification. If you watch our previous class, if you attend our previous class, you should know what we mean by magnification, right? And we said magnification is represented using capital M, right? So that capital M is equal to, said the image distance all over object distance, right? So in short form, I can say that magnification M is equal to image distance is V all over object distance is U, right? So we call this formula also. And we said in terms of height, we said magnification M can be expressed as height of image HI over height of object HO. So here's the idea. Magnification has to do with your image must come first before object. So image before object. So that's how you work on magnification. Just like the little formulas we established in our previous class. So with these few ones here and other things I will give you. Okay, also note please. Also note that the relationship between power, note that the relationship between power and focal length is given by power is equal to 1 over focal length. Another important formula to note please. I didn't give you this last class, so note that relationship between power and focal length is given by power is equal to 1 over focal length, as we have on the board here. All right, having said this, please, let's start solving past questions. Question 1, please. Question one says an object is placed 10 meters from a pinhole camera of length 25 cm. Full stop. Calculate the linear magnification. All right, so in this question there, we are asked to find linear magnification. First things first, it says An object is placed from a PO camera of length 25 cm. That object distance, right? So examples, number one, question one. Okay, question one, givens. So it says an object is placed 10 meters from a PO camera of length 5 cm. So it means that 12 cm, now says calculate the linear magnification, right? So it says, listen please, it says an object is placed 10 meters from a PO camera. An object is placed 10 meters from a PO camera. That's object distance, right? Object distance there is 10. That's object distance. That's of course 10 meters, right? We said this stops here has to do with cm. That gives you 100 cm. If you watch our previous class, our introduction, I explain why we are converting to cm. Go and watch it. I've explained why. All right. So we said an object is placed 10 meter. So object is placed. That's object distance 10 meter from a PO camera of length 25 cm. So that's what PO camera is, the image distance. So the image distance there, the image distance, that's of course 25 cm, 35 cm. No conversion, should be in cm. All right, moving on there. We are asked to find magnification, linear magnification. So I have to find a linear magnification. All right, that's of course capital M. So first things first, we know that capital M, as you recall very well, is equal to, we said your task is this: image to convex. That's image distance. That's image distance. That's image distance all over there, object distance. All right, from here, image distance, of course, image distance 25 cm. That's 25 over what's object distance there? Object distance, of course, 100. So it means that my linear magnification here, will be equal to all right. So M will be equal to by the divider stop there, that gives you 0.25 cm. All right. So that becomes how you solve that particular question. Sorry, 1000 meters to centimeter is 10. Sorry, please. Cm. So 10 meter is 1000 cm, please. So 1000 cm, please. That's 0.025 cm. All right. So we have the solution to question 1. Question 2 says the focal length of a concave mirror is 0.2 cm if the object is placed 8.0 cm from it. The image is at question mark. Option 1, option A, 2.0 meters. Option B, 2.3 meters. Option C, 2.5 meters. Option D, 2.7 meters. So how do I do this, please? It's simple as this, please. Your task is to list out what are given. Question 2, givens. It says the focal length of a concave mirror is, so focal length F is 2.0 cm, please. 2.0 cm if an object is placed. So that's object distance. That object distance. That of course of the object distance u. That of course what's the value? 8.0 cm. Moving on, there is placed 8.0 cm. From it, the image is at what? So image distance. Image distance is unknown, and that's v. So we are asked to find v, right? So first things first, it's possible for me to relate f, u, and v, because we're asked that this is a what? A concave mirror. So recall that for a concave mirror, we establish that the formula becomes 1 over f is equal to 1 over u plus 1 over v. So it means I'm asked to find this v. So let's substitute in value and see what we get here, what we arrive at. Take this off. Take this off. Okay. All right, please. So from here, if you check properly, 1 over f, that gives you 1 over f. F is of course 2 is equal to 1 over u. U is of course 8 plus 1 over v. V is unknown. So I can take this 1 over 8 here. That gives you 1 over 2 minus 1 over 8 is equal to 1 over v. My task to find LCM. So what's the LCM here? 8 is LCM. 8 in 2, that gives you 4. 4 times 1 gives you 4. Right? Minus 8 in 8 gives you 1. 4 times 1 gives you 1. Equal to 1 over v. At this point, 4 minus 1 gives you 3 over 8 is equal to 1 over v. My goal is to find v. What do? I'll simply cross multiply. That gives 3 times v gives you 3v is equal to 1 times 8 gives you 8. To get v, I have to divide both sides by 3. So divide it by 3, here by 3. This one will cancel this one there. So that v is equal to 8 over 3. This becomes your answer for v. In decimal form, if I divide 8 by 3, I'll have 2.7, of course, in cm. Of course, in cm, because it was given in cm. So this is how you solve this question 2, as you can see on the board. So let's move on to solve question 3 and see how this concept works. All right, question 3 says, Master one land observed his image through a plane mirror. He kept a distance away from him at 4.7 meters. Is in his room. At what distance is the image from Rwanda's eye? So this particular stuff here has to do with the plane mirror, right? So to explain this kind of questions, we need to draw diagrams. Aside diagrams, we need to establish something, right? Please notice, please. Whenever you get the word plane mirror, this stuff should come to your mind. Note please. One of the characteristics of a plane mirror is that the object is at equal distance from the mirror as the image. I said one of the characteristics of a plane mirror is that the object is at equal distance from the mirror as the image. So what I'm saying is this, please. So if I have a plane mirror, so these are a plane mirror looks. I have a plane mirror like this, something like this. So I have this like a typical illustration of a plane mirror, right? It's plane. So this is Mr. What's his name there? Mr. What's his name there? Mr. Wanland, right? And of course, um, the the image where his eyes was, the image was here. So this is the object here, and this is the image here, right? So object and image. Here is the object, and here is the image. All right. So Mr. Wonder was here. Mr. Wanland was here, right? So it says, listen to me. It says the distance. Sorry. It says Mr. Wanland observed his image. Observed his image through a plane mirror. All right. Kept a distance away from him at 4.7 meters. So from here to here is 4.7 meters. Then I'm asking you that in his room, at what distance is the image from one land? So from here to here, what is the exact distance? You know, I said know something that the one of the characteristics of a plane mirror is that the object is at equal distance to what there, equal distance from the mirror as the image. So it means that if from here to here is 10, it means from here to here is also 10. So if Mr. Wanland is here and the distance from object to the plane mirror is 4.7 as said in the question, it means that from this plane mirror to this image, the distance there is also 4.7. Why? Is a plane mirror. They will have equal distance. That's the concept there. So we are saying this place that they told us that from here, from the object here is 4.7 meters, right? And we said from here to here, automatically because what there, 4.7 meters. Why? Because they will have the same distance. So the distance of the object and the image must be the same in a plane mirror. They must be equal to each other, right? So in other words, we are asked to find the distance from Mr. Wanland to the image. So it means that I'm summing up these two distance. So therefore, the distance becomes 4.7 meters plus 4.7 meters, and that gives us 9.4, yeah, 9.4 meters. So this is how you solve problems of this kind. Get the image, the object, that's Mr. Wanland, and the image, right? And you have a plane mirror here. So distance from the plane mirror to the object is equal to and is similar to and is the same as distance of image to the plane mirror. So they must be the same thing, right? So this is how you work with this particular kind of questions, please. This is how you solve question 4. I'm correct. Yeah. So question 3. That's it, please. Let's do question 4. It says determine the focal length of a thin converging lens if the power is 5.0 dioptry. All right. So that's like the okay. Look at this, please. It says determine the focal length. So question 4. It says determine the focal length. So for focal length, we are asked to look at focal length. So focal length, this is a short form. F is unknown. Okay. Of a thin converging lens of a power here is given as 5.0 dioptry. That's capital D is the symbol for representing that word on the screen. That's dioptry, right? So we know I established something before I started today's class. I said that there's a relationship between power and focal length. So of course in this place here we have to bring in that concept here. So it means that we said power is equal to 1 over focal length. It's equal to 1 over focal length, of course. Sorry. So it means that, all right, and just power is of course 5 is equal to 1 over focal length. How do I get focal length? It's simple. I can choose to swap each other. Better still, for understanding sake, I want the cross multiply. That gives you 5 times f gives you 5f is equal to invisible 1 is the 1 times 1 gives you 1. To get f, what do I do there? Divided by 5, divided by 5. So it means the focal length f here will be equal to 1 over 5. So this is how you solve problems of this kind. When you have a relationship between focal length and power, this is how you solve problems of this kind. This is question 4, and we're still going to question 12. So we're doing 1 to 12, and we're still at question 4. So let's double up. Let's move on, guys. So let's do question 5. Question 5, please. All right. It says the distance between the image and the object in a plane mirror is 40 cm if the distance of the object is reduced by 9.2 cm. What is the distance of the object from the mirror? This is similar to question 3. We have to draw our diagram to explain this map. And I say, listen to this place. It says the distance between the image, distance between the image and the object in a plane mirror is what? There 40 cm. So it says from here to here is 40 cm. No problem. Moving on there, it now says if the distance of the object is reduced by 9.2 cm, distance of the object, that is from here. Let's do question 6. It says if a convex lens of focal length 12 cm is used to produce a real image 4 times the size of the object, how far from the lens must the object be placed? Let's list out what we are given. So it says all right, it says question 6 says question 6. It says if a convex lens of focal length 12 cm, so focal length, that's f, 4 cm, moving on there, 12 cm, please, 12 cm is used to produce a real image 4 times the size of the object, comma. That says how far the lens must the object be placed. So how far, it says how far from the lens must be object be placed. That's object distance is unknown. Object distance, that's u, is unknown, right? But here is tax here. Whenever you get the word, the pattern in this form, listen please. Listen to this part. It says produce a real image 4 times the size. When you hear the word 4 times the size, or 2 times the size, or 3 times the size, or whatever times the size, that thing is talking about magnification. Please know this thing, please. Copy this down somewhere. Note, whenever you see any image 4 times or 3 times or 2 times the size, whenever you see an image 4 times or 3 times or 2 times the size, comma, it means magnification. It means magnification. So look at what I place. In this case here, it was 4 times the size. So it means that magnification, that's m, is what? That 4. So I'm given this list. So we are asked to find u. So I'm given m, f, and object. So what comes to mind here? What do I know comes to mind here? So what do we know? What do we know? What do we know? So first is first. I think we need to we know something fully well. What do we know? So we know that m is equal to v over u, right? And I'm asked to find u from here. Let me make u subject. It means that u will be equal to what there? mv, right? So u is equal to what there? mv, right? So in other words, this whole picture, the focal length here was brought from the idea of what there? The idea of convex mirror. Let me check please. It was convex, yes. It was convex mirror. Yeah, convex mirror. Hold on please. Sorry, if I try to make, look up please. If I try to make u subject of having a fraction, please, sorry, that gives you v over m, right? In that case, right? In that case, but my goal is to find u, right? My goal is to find u. So if my goal is to find u, I don't need to make u subject. I need to make v subject. In that case, right? Sorry for the mistake. I'll explain why I need to make v subject. So v will be equal to what there? mu. So I'm saying that v equal to what's m? M is 4 for u. So the idea is this, please, that this particular focal length was brought from the idea of what? Of convex mirror, and now we have a negative in the middle, right? So hold on. So from convex, so for convex concept, we said that gives you 1 over f equal to 1 over u minus 1 over v. We are asked to find u. So why I said we should not make u subject here, because we're going to be complexing the stuff there. We'll complex it, right? So make v subject and replace this v with what? 4u. So everything here now becomes u in general. So it means that 1 over f, that 1 over 12, is equal to 1 over what's u is unknown minus 1 over what's v? V is 4u. My LCM here is 4u. So 4u in u gives you 4. 4 times 1 gives you 4 minus 4u in 4u is 1. 1 times 1 gives you 1. This is equal to 1 over 12. So it means that 1 over 12 will be equal to, this gives you 3 over 4u. The goal is to get u, right? So I have to multiply. So cross multiply. That gives you this time. This gives you 1 times 4u equal to this times 12. That gives you 12 times 3. This one gives you 4u equal to 36. I'll make you subject by dividing both sides by 4 to get the value of u. So that gives you 4u over 4 is equal to 36 over 4. So this 4 cancels this 4. U is equal to 9 cm. Let's solve for this particular question, as you can see on the board. So let's move on. Let's do the question 7 and let's see how question 7 works, please. Question 7, it says an object of height 4 cm is placed in front of a cuboid pinhole camera of size 6 cm, right? If the image formed is 2 cm height, how far is the object from the pinhole? So let's solve this problem, please. It says an object of height 4 cm, that's height of object. So that's height of object. So height of object is of course 4 cm is placed in front of a what? A cuboid pinhole camera of size 6 cm, right? Of size 6 cm is placed in front of a cuboid pinhole camera of size 6 cm, right? That's the image distance, right? Image height per se. Image height is of course 6 cm, right? And height, because it says is placed in front of a cuboid pinhole camera of size 6 cm. It says if the image form is 2 cm, so image form is 2 cm. Sorry, please. Listen to the issues. An object of height 4 cm is placed in front of a cubic of 4 cm. That's object of height 4 cm is placed in front of a cuboid pinhole camera of size 6 cm. So it's placed in front. That's distance. That's distance of what there? Distance of image distance. That's V. Please, image distance, that's V. If the image form is 2 cm, right? Height, so that's image, that's height of image is 2 cm. How far is the object from the pinhole camera? That's U. So how far is the object from the pinhole camera? So object distance is U, right? While image distance in front of image distance is V, right? So that's how we have. So we have given this list. So we have to find U. So you can see that this kind of you are relating two things together, right? You know, we established that M. We said M is equal to V over U. We said M in terms of height is what the height of image over what the height of what object. So it seems that these two are coming to play here, right? Because I'm having HO, HI, right? I'm still having V and U. So we have to find this U. So what do? We're going to what? Equate the two ends together, right? So equating the two ends together. So that is this. You have to make sure you read the paper properly to get to know which one is the object distance, image distance, object height, and image height, please. Okay, so equating to M, so I'm saying that M is equal to M. So what's the first M? That's V over U is equal to HI over HO. We use this equation to solve the value, to get the value of V. So what's V? V is 6 over what's U is unknown. We have to find U. What's HI? That's 2. What's HO? Object height, that's 4. To get U, I have to what there? Cross multiply That gives you 6 times 4. This gives you 2 times u. 6 times 4 gives you a value of 24, equal to 2 times u gives you 2u. Let's get the value of u here. After divide both by 2, get value of u. Divide both sides by 2 to get the value of u. That's 42. 24 over 2 equals 2u over 2. So let's cancel this. So I'm saying that u is equal to what there? 24 over 2. And u is equal to 12 cm. This is the value of u in this particular question. Let's do question 8, please. Let's do question 8, please. Question 8. Question 8. Question 8 says, an object of height 5 cm is placed at 20 cm from a concave mirror of focal length 10 cm. The object height is dash. Option A, 20 cm, B, 15 cm, C, 10 cm, and D, 5 cm. How do we solve this? It says an object of height 5 cm, that's height of object. Height of object is 5 cm, is placed at 20 cm. So that's object distance. Object distance. Object distance. That's 20 cm from a concave mirror of focal length 10 cm. So focal length F is 10 cm. The image height is what? So we are asked to find image height is what? So I am still gonna bring up the idea. Object distance, that's u. So yes, that's u. So let's say we can work with this, please. So I am in HI u, but there is no v here. If there was v here, I'll bring up the idea of this formula back. V over u equal to h over hi over ho. But here they give us focal length f, and we are asked to find hi, right? That's image height or height of the image. What do we do? And it will give us focal length f, and in this case our focal length here f is given by, is it the concave, right? Yeah, the concave. Is it concave? Yes, concave, the concave. So what do we do here? Our best priority, please look up, please. Look up, please. Solution to this question. So what do we do here? My very first task here is to recall for concave mirror there we said that 1 over f is equal to 1 over u plus 1 over v, right? It is true. Our task is to get hi, right? Moving on, please. So this gives you 1 over, what's f? F is 10. 1 over u. U is what there? U is 20 plus 1 over, I don't know the value of v, so I need to know v. Anyways, take this one here, that gives you 1 over 10 minus 1 over 20 is equal to 1 over v. My sum here gives you 20. 20 in 10 gives you 2. 2 times 1 gives you 2. 20 in 20 is 1 times 1 gives you 1, equal to 1 over v. So in other words, it means that this gives you 2 minus 1 gives you 1 over 20 equal to 1 over v. Multiply, that gives you 1 times 20 gives you 20 equal to 1 times v gives you V. So V is 20. So therefore, I'm saying that V is what? 20 cm. That's the value of V. Now, we're not asked to find V. We're asked to find height of image, height of image. So what do we do there? Now, since now I know U, I know V, I know HO, I know HI. I don't know HI, so I can bring up that idea of our formula of question 7 that we used earlier before now. So I'll bring up the idea of V over U equal to what there? HI over HO, equating two M's. You have this place. So V is 20 over U is 20 equals HI is unknown. We have to find HI. What's HO? That's on 5. That's 5. To save my time, 20 and 20 is 1. So I shall have 1 here equal to HI over 5. Over 5. In other words, let's proceed. In other words, I will multiply here over 1. What times HI gives you? HI, that's image height, is equal to 1 times 5. 1 times 5. So HI is equal to 5 cm. Alright. As I solve this particular question, that's all, please. As I solve this question. So question 9 says, question 9, it says, convex mirror are used as driving mirror because image form are option A, erect, virtual and diminished. Option B, erect, real and diminished. C, erect, virtual and magnified. D, inverted, virtual and diminished. We watch our first class on convex mirror. I said a convex mirror is erect, virtual and diminished. So watch our previous class, you should know the answer to this. So option A is my answer to question 9. Question 10 says, a person approaches a plane mirror at 5 meters per second. How far do they approach the mirror image? Option A, 7.5 meters per second. Option B, 10 meters per second. Option C, 2.5 meters per second. Option D, 5 meters per second. So it's simple. You know, we said something about plane mirror, that the image and the object and the plane mirror is at the middle. The distance from the image to the plane mirror is the same thing as the distance from the word there, the plane mirror to the object. So we are saying this, please. It says if that plane mirror was approached with 5 meters per second, right? So it now says how far does it approach the image, the mirror image? It's what there, since they're saying 5 meters per second. So my answer there is a what? Option D is my answer to this question. Take question 11 and 12 assignment, please. 11 says the magnification of an object 2 cm tall when placed 10 cm in form of a plane mirror is dash. Come again. The magnification of an object 2 cm tall when placed 10 cm in form of a plane mirror is dash. Option A, 6. Option B, 10. Option C, 0.7. Option D, 0.1. Of course, they are all okay. That's please. That's my options there. Question 12 says 11 and 12 assignment, please. Question 12 says a pinhole camera is placed 300 meters in front of a building so that the image is formed on a screen 5 cm from the pinhole. Full stop. If the image is 2.5 cm high, the height of the building will be dash. So you are left to do 11 and 12 as an assignment. So I have done 1 to 13, sorry, 1 to 9. You do 11 and 12. Please leave your answer in the comment section for 11 and 12. Please avoid using AI. Do it first, right? Make mistake, then you can seek for corrections, right? So this is how you work with these particular formulas using the idea of mirror formula. Don't forget, I'll leave the introduction to mirror formula in the video description. So do well to like this video, subscribe to my channel, leave a comment, and share this video to your classmates, your course-mates that also will be interested in learning the idea of mirror. So see you guys in next class. Also do well to read my description. I leave my WhatsApp community, WhatsApp channel, WhatsApp group link. They are there, and also my social media platforms. Also, the links are there. Do well to follow me through my handles. See you guys in the next class, and welcome to Excellent Link Academy.